and maybe, why did you come here today, or what's your interest is. Why don't we start over here with Derek?
Derek Zero. I'm an architectural design for AZ Design Services in Hartford, and came to see if you run presentations.
Okay.
I work for high school partners on this pro here in Hartford. We can see how we can make our BIM model more effective and more productive.
Fantastic. Yeah, I don't think you've been here before, have you? This is the first time? Okay. Well, hopefully you'll find it enjoyable. So. Who are you?
Dave O'Coin, Director with PES Structural Engineers and co-chair of the BIM Council with David here. This presentation resonates with me. We're sharing our models downstream all the time, so always want to be aware of how best to model so that they can further our communication.
Bill Floor with Shuzak Associates. We've been getting more and more requests for our models from contractors, so seems relevant to come.
Great.
Jonathan Zwick with Shuzak Associates, and basically just to see how the models are being used and if there's anything that we can do to improve use by other people.
Okay.
Paul Wojcicki with Shuzak Associates, and pretty much for the same reason those guys are.
You can sit separately, Just kidding. Great.
I'm Sharon Zwick with MBH Architecture, and just keeping up to date with how everybody's interacting with BIM and trying to keep up with the latest trends.
Okay, why don't we come back here to Tom?
Tom Lane from Park Architects, and my interest is in
Yeah, there too. Human resources there. This is our grad student.
Fantastic, thank you for coming.
Joe Orlando, project director for AD Construction, and I guess like everybody, just trying to stay in touch with the latest uses and sharing of the models and making sure we just in touch with where the
This is your first time here also. Did you have a long ride this morning?
A little over an hour.
Okay, I know your office is standing. Thank you for coming.
I'm Ryan Sullivan from AD Construction as well, assistant project manager there. Just coming to see architectural and architectural side of us and see if we can get communication as far as construction side as well.
Interesting. See, you don't have to work with the architect. Go ahead.
Joe Kenny from PES Structural Engineers. Just here for the next little tour today.
Great.
I'm Andrew Goldstein. I'm also with PES Structural Engineers, and kind of see if there's any ways to help them do their project.
Nick Castle, OMG Industries. Pretty much seeing what else I can do with the models as a contractor.
Rebecca Hopkins, technology, pretty much everything everywhere.
Good. When we go to
Juan Pitto, Ken Fortune Architects in New Haven. Also one of Jeff's students as a graduate student.
My name is Tom Freund. I owned digital built some licenses, oversight systems for equipment. And my interest basically is in the intersection of BIM and facilities management, and more particularly how BIM can enhance the capabilities of facilities management for facilities management.
Great.
Steve Hill, Spectrum Architects, same as everybody else.
Okay.
Bob Hayes, retired from Siemens Power Generation. I'm just interested in staying up with the technology.
Mike Hart from Santa Barbara Architects. I'm a digital design coordinator there. Who would want to miss a presentation by Jeff, the great kid?
Nick Ambrosino with Daniel O'Connell's Sons. Here to see if we can pick up anything on how others are using models in construction. Okay, great.
Elena Ansel, Daniel O'Connell Sons. Ike and I work together, and I'm hoping to learn some new ideas how we can use models.
Okay. I think that's it. You came in late, so go ahead. I don't miss anything.
Lynn Temple with Turner Construction Company, and I'm chief estimator for our Connecticut office, and also the Jeff from Hard and work with us. So
great.
Thank you to support.
And Lynn hasn't seen this presentation yet.
I don't know much about it.
Fantastic. I think we had a couple late people come in, but we're just doing introductions. So where are you from?
From Point One Architects. My name is Kelsey Gusty.
Okay. And what drew you to the presentation, please?
Just to learn.
Okay, fantastic.
Same
thing. Okay, great. Well, with that, we're going to turn it over to Nancy.
Okay, thanks. So I'm Nancy Greenwald, and I am the Executive Director of the Construction Institute, of which the BIM Council is a part. Our mission really is to promote cross-industry collaboration, and I always say this group really is at the peak of that mission, because we're bringing together people from all aspects of the industry who are all engaged in this a similar process of working with these models and trying to improve that. And they're terrific programs, and kudos to Dave and Dave for all the work they've done putting these together. And thank you to Seth for what I know is doing another presentation this morning. So now I become the equivalent of the ad you have to watch before you get to see the YouTube video if you really want to like that. We have, in addition to the BIM Council, we have a lot of really interesting types of programs, many of which are geared around the question, how do we do things better, how do we collaborate? Industry Redesign, which is coming up on December 1st, is really a workshop kind of a program. It's a different kind of a program than any you might have been to. And we're really putting people together to talk about ways of how do we make this industry more collaborative? Let's stop talking about it and think about how we can actually do it. Our owners forum is going to be talking about innovative project delivery transformation. So we'll have some, Tom Warner from Arcadis will be talking about the view from 30,000 feet. And then we have 3 teams of owners, architects, and contractors coming in to talk about specific projects that they've worked on with different methods of integration, including one that's a true IPD project.
And the moderator is going to whip them all into shape.
Yes,
right?
and our moderator is here. David Coyne will be the moderator for that program. Thank you. And then, we have classes as well. For those of you who are students at UHARD or faculty at UHARD, all of our workshops here are free for you to attend. So anything that you're interested in, you can come to. These are, of course, available to our members and to the public as well. So facilities operation and maintenance management is coming up tomorrow. Budget scope management in December. And railroad bridge engineering in January. So with that, I'll turn it back to Dave.
Thank you. So the BIM Council actually probably started somewhere between 6 to 8 years ago, and it's grown very nicely. The reason has to do with the group here that works on planning. That brings you, topics and discussion points and speakers like what you're seeing today. We are going to be taking some time off for December, but we can't really do much without our wonderful sponsors. So we want to thank Divya Construction Company, who has been our seasoned breakfast sponsor throughout the year, and PS Structural Engineers for allowing us to utilize the web conferencing services. Our schedule will be posted on the CI site in the very near future. At least here's the open dates. If you send me an email, I can always send you this, but primarily going to always be the 3rd Wednesday of every month, and we alternate months where we'll do a BIM breakfast. Probably January, February will be BIM and beer. Maybe BIM, beer, and wine. I don't know. We'll talk about that. And we'll continue through at least the 11 months. The great thing is that we already have some topics and speakers lined up, probably at least through the first 4 or 5 months. But we're looking for input from you, because this works because we want to focus on what you need to learn about, what you hear about in the marketplace. If you travel, if you go to events like the BIM Forum or Autodesk University or RTC or any of those things, we want to hear what's happening so that we can then talk about it within this region. Because as I said, at some point you're probably going to cross paths and be working together, and this just helps really bolster that higher level of collaboration. And now we're going to get into this, and hopefully we have a couple of people on from Autodesk University. I don't know if I saw them on there, but Jeff, thank you very much. And I got to say, you got married about a month ago. Congratulations. Thank you very much.
All right. How's everyone doing? Good. All right. So, I guess to start, it's early in the morning. I know, so thank you for coming out. I know it's not always easy getting to this part of Connecticut. I've done the drive plenty of times myself. Those of you who came from far away, thanks again for that. So to start things off, I like to go a little lighthearted and something with a little bit of a lesson. And I think in our day-to-day lives and the daily grind of deadlines, hey Steve, what's going on? What's showing up, bud? It is to sort of remind us of some things that we might have forgot. And I think it's very easy to forget. So I want to start with a little cartoon, and it's going to be the theme throughout the entire presentation. Unfortunately, the speakers are only on here, so let me... Anyone hear that all right?
Tip and Tom usually went out together, but Tip had a lot of things to do in the house, and had decided it was safe for Top to go out on his own. Top knew the forest well, and there was no chance he would get lost. He would have a nice walk, play some things, and go home. Top had never seen anything like this before. He was a little bit scared about Tip. Top hoped the thing would go away. Top didn't have Tip to hide behind, so he got that little boulder. He was still not absolutely sure, but plucked up his courage all the same. Now that he caught the balloon, what could he do with it? Maybe he could use it to help him fly. What he wanted to do first was show his balloon to Tip. Tip had lots of things to do, but he would have to wait. It wasn't every day he had a balloon to play with. Top didn't really want to share his balloon, but Tip was his friend, wasn't he? Tip was going higher and higher, and Top was beginning to feel jealous. When Top got the balloon back, he was determined it could help him fly. But as so often with Top, he hadn't thought of what would happen if he did manage to fly. He'd lost his balloon, but luckily Top was all right. The balloon hadn't gone far, and Top had no intention of losing it. Tip watched as his friend kept failing to catch the stream, and in the end, Top gave up and asked Tip to help. It wasn't difficult for Tip, who was not so tall. Top grabbed the balloon and started to play again. Then he stopped. Maybe his friend would like to have a go too. Tip told Top to wait while he went into the house to fetch them. When he came out, asked top to give him the scoop. Top wasn't exactly happy, but gave Tip the scoop. He was very curious to know what Tip could possibly be doing. When he finally understood, Top was delighted. Now they could both hold on to the balloon.
Alright, so that was Tip and Top. What do you think? Pretty cool, right? Ever heard of Tip and Top before? Yeah, me either. I found it when I was looking for cartoons about sharing. I like the accent, so I used it. But the metaphor is there, right? I want you to make your own analogies and metaphors, and throughout this presentation, we're going to go back to Tip and Top. But think about the lessons there, right? The lessons of sharing, but also the lessons of the combination of Tip and Top together made something better, right? So we're going to go throughout this whole thing, and I'm going to go back to Tip and Top, and we're going to kind of tie a little bow on it. But that was a nice way to sort of lighten the mood, as well as remind us of some of the lessons we always forget in day-to-day life, budgeting, constraints, etc. So I had a whole 3 slides here to ask who architects, engineers, and contractors are. We kind of went through that, but I'll go through it again. Please raise your hand if you're an architect, or on the architecture side of things. All right, put your hand down. If you're an engineer, or on the engineering side of things. And if you're a contractor. All right, so we do have a really good blend, which is cool. That's nice. Like my contractor tells me. Don't take any offense to it. Tweeting is highly encouraged in my talks. So if you are on Twitter, I'm at the Revit Kid. Make sure you post or tag me in any photos, etc. I know that it's something that we can't avoid these days, so you might as well encourage it. So now, when it came down to the abstract, so this is a little adaptation from a presentation I gave at Revit Technology Conference. And so you submit an abstract 6 to 9 months before the conference, and really it's a title and a little bit of a summary. And so I submitted a couple. You usually submit 1 or 2 or 3 if you really want to go. And they chose this one based on a title, right? How are contractors using my model? So once it's chosen, now I have to actually figure out what the heck I'm going to talk about, right? So how do you sort of bunch this in a way that's digestible, easily remembered, and easy to follow? And so in the construction industry as well as the design industry, we love our acronyms, right? I mean, we're at the BIM Council, right? BIM's an acronym. BIM, BDC, CSI, CI, RFI, ASR. We can go down the list. AECO. You can go down the list. We love our acronyms here, right? So I figured I'm going to make my own acronym, and it's going to help sort of categorize all the different uses of the model, as well as hopefully make you guys remember it down the road. So VICO is the acronym we're going to use, and what it stands for is visualization, extraction, construction, and operation. And so in my everyday life at Turner Construction, these are really the 4 categories that say that I'm touching BIM or models or any type of this technology side of things. Okay, so these are sort of the categories and the buckets. So we're going to run through each of these categories, and I'm going to give some real world examples as well as some theoretical examples on how we're using them. And the reason why I decided to go this route and make it a little more informational instead of preaching to you and share your model, because I think the preaching part is what people have been doing, right? They've been saying, yeah, you need to share a model, you need to share a model, you need to share a model. And that's fine, okay? You do need to share your model, but I think the reason people are so hesitant to share the model, especially on the design side, me being from the design side, I completely understand, is the fear of the unknown. So the best way, instead of preaching to you about that you should be sharing your model, I think most of you know that there's value there and you should be, but you have no idea what happens to it when you do share it. So I think by just informing you about what happens downstream, at the end of this, you're going to say, hey, it's not that bad, and that's the goal, okay? So we're going to start with visualization. This, to me, being an architect, is probably the most valuable part, because I'm such a visual person. And as contractors, I think seeing the end product can be very important. And so what we do on a day-to-day basis, especially as construction managers, is critical path scheduling is huge, right? Logistics and planning, figuring out how things go, and of course estimating, and then buying out the project accurately and at the best price. So the visual, although it may not seem like the most important, the cost and the information might be, but the visual helps us not only understand, but also helps us explain it to owners and our subcontractors that we're trying to buy the work. Just like you as architects and engineers use visuals to explain the design to the owners before you get hired. So Lynn, you're going to love this slide. Lynn and I talk about this all the time. the process now and the process that we've created as an industry, right? Think about the process of construction and design. What do? As architects, you sit there and we sketch out a parquet, a diagram, a floor plan, elevation. There's some sort of two-dimensional sketch that's usually created on a piece of trace, or maybe on an iPad, or maybe on a surface, whatever, right? It's a two-dimensional sketch that's being drawn. Then using Revit, hopefully everyone's using Revit, if not using some sort of BIM software, ArchiCAD, Revit, you're creating a 3D model of that. And you use that for rendering, use that for explaining your design, use it now to create 2D documents. So we went from a 2D sketch to a 3D model. Then we take the time, and how much time do you spend creating a 2D document from your 3D model? Probably 80% of your time in a project is spent doing that, right? Then we go back to a 3D building now. As construction managers or subcontractors, we have to take those 2D drawings and rebuild them. If you told anyone in any other industry about this process, they'd probably laugh in our faces, right? It's silly, it's crazy. But it is what we have right now. And hopefully one day we will eliminate some of these 2D processes, maybe this one here. But until we do, we need to figure out ways to really sort of expand and take the information from this space and use it now. And so that's where these visuals come into play, especially. So logistics and planning is a huge part of what I do as construction managers. A lot of it is planning out the project, planning out how something's getting built. So having a 3D model, as you can imagine, especially architects and engineers, having that 3D element to explore aspects of the building is extremely valuable. So I want to give you some examples of how we use it. And so this is a project at Sacred Heart University. I think we have anyone from SLAM here? We have someone from SLAM here, and I think on the phone, right? Or no? No. So this is Sacred Heart University's Bennett Hall. So we're working with SLAM on this project. SLAM was nice enough to let us use the model for this project. And so what we did is, during the proposal phase, and now even carrying it into construction, we took the model, it's a renovation, this is the building here, build a site around it, because there's a lot of site aspects that are important. We're taking down a huge building behind it that we're demoing. And we're able to create these not only visually interesting, but they tell a big story about the project, right? We have scaffolding on the front that's very important. There's some scaffolding on the side that's important. We're trying to highlight the important part. And all we did was take SLAM's model, brought it in, hid some of the stuff that's getting demoed so it looks like it's under construction, and now it's just this reference piece, right? We're not measuring windows and doors and stuff, right? It's just a reference piece, but it's super powerful and super visual. Again, now we can move down to the other side, and there's a couple really important parts on this project. Initially, I don't know if they're still going to do it. There's a big scaffolding chute system we're doing 5 stories of renovation, so getting stuff in, getting stuff out is really important, right? Especially on interior renovation. So we wanted to illustrate to the owner and to SLAM and to the engineers, pretty much to everyone, now to subcontractors, how we plan on doing this. What is our plan for moving and putting stuff into the building? So again, the model just becomes this backdrop. It's a reference for it. But look how powerful that visual is, right? I probably didn't have to speak. I could have went through these 2 slides and you completely understood what we were going to do in this project. Moving down the line, instead of just the photorealistic video stuff you just saw, diagramming stuff can be really good. And you can tell I'm an architect, right, by the way these diagrams are. We love our diagrams. But downstream, they can also be very valuable. On the left-hand side is actually the state office building. This is a proposal that we did not win, but it's a good example of a diagram that shows how we're going to flow out of the building, because we're demoing and renovating the inside. And again, this was a model. Actually, we created this model in-house because it was during proposal phase and we didn't get it yet. But let's say this was given to us, right? We could just simply cut a section box, throw in these diagrammatic pieces, export an image, and now we can say, hey owner, this is how we plan on building your building. Super valuable, right? Or hey architect, this is how we plan on building your design. On the right-hand side is a project we did win. It's in it's in Middlebury, Connecticut, and this one was pretty cool because it is an all-girls school, and we had to renovate different aspects of it while girls were living there. So if you think about it, middle school or middle to high school, all girls, and now you've got a bunch of contractors. Right? You want to segment them as much as possible, right? And so what we did here is just by showing a diagram of the model, we can explain how we're going to isolate these 4 rooms. We're going to use scaffolding. We're replacing the windows anyway, so let's go in the window. And now we've got this separate entrance that we're going to march around the building. We're going to renovate these dormitories without ever having the young females and our subcontractors interact. So I don't have to go too much more into that because the visual tells you such a good story, right? So this is what we told the owner, and this is what we've used for logistics planning downstream. Beyond logistics, virtual mockups are becoming extremely valuable and important, I'm sure. Everyone here has seen physical mockups, right? Most of the time they're required for specific things. masonry, etc. You're building walls. But physical mock-ups can be expensive, they can be time consuming, and there's also lead times to think about. There's dealing with subcontractors earlier. Maybe you don't want to have the masons on site, but they got to come on to build the field pallet, etc. So we found that virtual mock-ups, so building virtually these little teeny pieces of the project, whether it's showing a sequence of details and how they go together, or whether it's actually just seeing the look of it and showing an owner, hey, this is what it's going to look like, you know that. Or showing the subcontractor. We found some value in that. And so one example, again, is that Westover school I was just talking about. One of the things that we're trying to demonstrate to the owner, this is very diagrammatic, obviously, but is that we were going to replace the windows from the inside instead of the outside. And this was a big thing because, again, it's a school that's being populated. There's a whole bunch of issues around it, so we were just showing a quick diagram. So now the project exec or the project manager who goes in front of them has a nice B-roll they can talk about. And say, hey, we're going to remove the weight, we're going to pull it from the inside and go through the process. Then there's the problems that virtual mock-ups can help solve. This is Yale Center for British Arts. You guys may be familiar with the project. It's in New Haven on Yale's campus. It's the Lewis Kahn building. Really cool building. Turner renovated it, working with Knight. Was it Knight? Was that Knight? Yeah. Really cool project, but we had some issues. They were replacing these fire shutters, or some of them didn't have fire shutters, but they were replacing with new fire shutters. Well, this thing right here is a clutch for the fire shutter. And that was installed that way. We have to reuse, it's a renovation and it's a historical building, so you have to reuse the wood, all these wood pieces, and you have to place them back in. You're pretty much stuck with the size that was there. So after installing one, we realized, oh crap, there's an issue, right? We don't want this clutch sticking out. We're cutting the drywall, it's not going to work. So what we did is, taking the existing conditions, taking the information from the fire damper company who does the fire shutter, we're able to locate the actual, now we have shop drawings, all the good stuff, we're able to locate the actual clutch location for all, I think it was all 4 or 5 stories, and it was 2, 4, 6, 8 per floor that we had the fire shutter. So you imagine this escalated, and if we had to do this every single time, it would have been expensive. And so we were able to locate every single fire shutter correctly beforehand without having that stupid clutch stick out. So that's a good example of a virtual mock-up that not only is giving you a visual identity, but it's also helping the owner and everyone else involved save time and money. And then finally, scoping. And so, does everyone know what scoping is, what scoping out a job is? Have you heard the term? Raise your hand if you've heard the term scoping. Okay, so about half. So, what scoping is as a construction manager, right, if we're given a set of documents and we are hiring subcontractors to do it, scoping is really making sure that we're buying all the right stuff and making sure that everything is being purchased and the work is being purchased to be built, right? So missing things in scoping obviously can be a big issue down the road, because then there's cost added, there's crap that doesn't get built, or you realize it's not built in the field, and then, oh no, what am I going to do? So obviously, visual, when you think about scoping, they're owning the documents, they're looking at documents, but they're looking at a set of 2D documents, okay? One of the things I like to think about when it comes to scoping and sort of actually building something is Legos. Okay, everyone in this room, I would assume, has built Legos at one time in their life. If you haven't, you need to go get some Legos and build Legos, because we all should have built Legos. Okay. One thing you'll notice in almost every single set of Legos you buy ever is that all the documents look something like this. And these are documents, right? We're showing you how to build something. Well, guess what? If you see a plan, section, elevation, or detail of a Lego, right? We're not telling a 4-year-old, to look at sheet A203 to figure out how tall their Lego needs to be, right? So this to me is super, super valuable, right? We're looking at this, and not only are we seeing all these pieces in between, it's not reasonable to say, here's every single process of putting the building together. But what's really valuable is right there, right? Let's go beyond Legos. IKEA furniture. I'm sure everyone here has built at least one piece of IKEA furniture in their life. If you're like me, you don't go through all this. You open to the last page and look what the damn thing's going to look like at the end, right? I mean, that's what we all do. Granted, it's not necessarily the best thing to do, but this last thing at the end, that's your model, right? So imagine being a subcontractor looking at 200 pages of 2D documents without ever looking at the last picture, and now go out and build a thing. Think about that, right? The process is crazy. So scoping, especially using a model, helps alleviate that process. We've had scoping meetings where we'll come in, we'll spin a model around, and you might have a mason that goes, oh, that's what that corner looks like. Because let's be honest, you can't show every single piece of the building in a 2D document. It's just not going to happen. So I just wanted to give a couple examples of scoping and how they're important. This is Bridgeport Hospital, which is a big emergency power upgrade that we're doing. at Revit Hospital. And this only required about three major subs, electrical, concrete, and site subcontractors. But it's a really tight site. There's, I think it's 450 conduits, and I don't know how many duct banks running from this new emergency power up to there. And so the model here, working with Shepley, actually Shepley Bolton, they shared the model, so it's sort of a mix between our modeling capabilities and theirs. And we were able to sit down and sequence this process, and we actually had this image here was a series of about 10 images, and it was probably one of the most important things, the most discussed things during the scoping meetings. Because we're saying, hey, this is what we think, what do you think, this is what we see, what do you see, and it was extremely valuable, and that project is actually, I think right now, it's very successful. It's they're flying, they're almost topped out with the flow of fill, and it's only been 40-something days, it's crazy. So that's really the visualization side thing. I'm going to end with a little story. I like to tell the story because Steve's here. Steve, this was Steve and I. Before I started working at Turner Construction, this was my introduction to Turner Construction. So this was my baby project. Steve and I worked on it for about 5 years with another project manager, and Dan Davis as well. Some of you might know Dan Davis. And so this project is Prospect Elementary School in Prospect, Connecticut, and came out really nice. We did this completely in Revit, but it was Steve and I, and I'm sure some of you can sympathize with that. 88,000 square foot, brand new school. Steve and I were the only two people putting together a set of documents on the architecture side. I'm sure some of you sympathize because I know it happens. I 100% know it happens. We got 140 people in the firm, we're still going to have 2 people working on each other. And so, we know we can own up to it, even though we're using Revit, and Steve and I believe, are pretty good at using Revit. We kind of know our stuff, right? There's still stuff you're going to miss in the 2D documents. It just happens, right? Two people can't possibly think of every single part of an 88,000 square foot building that you need to document. Sorry, especially in a state job where you have all that state stuff going on. You're sidetracked a little bit. So I wanted to show this image because this was a project where Turner did do 3D coordination. Again, I wasn't at Turner yet, but they did do 3D coordination. But the job team, the field team, was not doing the model. They were using 2D documents. They had the model. They were handing off to subcontractors. They were doing their thing with coordination. But the field team was never really looking at the model. They didn't actually see it. And so we had some issues in this corner here and under here, where we're going from a vented roof to an exposed steel structure, and there was a couple things going on. There were some details there that, for whatever reason, probably about 2 months of back and forth with RFIs with the project team, it just wasn't. They weren't understanding it. We were trying to figure out how to explain it. And then I remember going to the weekly meeting down at the field, and I actually brought my laptop, opened up the model, and I just spun underneath. And I remember watching Dave and Phil, were the 2 guys in the field for Turner, their jaws just dropped as they spun around this model. Because the first time they saw this model in 3 dimensions beyond those 2D drawings, and immediately there was like 7 or 8 questions that completely answered just by spinning it around. It's questions that were just lingering in their mind. So that's the power of visualization, and that has nothing to do with your wall types and your modeling techniques and your whatever, right? This is just visual. This is just being able to look at the finished product, just like Legos or IKEA and so on. So pretty cool, right? It's visual. I think it gives you a little example of what we do. Now this is the part where I feel like we should close the doors, because this is where the architects and engineers are going to run. This is the part that scares the most people. And I'm hoping by the end of this, you're not as scared, because I promise you it's not that bad. Okay, so extraction. Extraction is when we're going to talk a little bit about quantity takeoff. Okay, estimating. So we're going to be pulling quantities off of your model. Okay, it's happening. It happens a lot. So get used to it, and I'm going to explain to you that it's really not as scary as you think. Okay, you can see here I'm saying 5D. Some of you, I don't like the D's personally, 4D, 5D, but I put them on here because I know people associate those two. So we're going to talk a little bit about quantity takeoff. So this is the part where I hope I don't offend Lynn too much, but I'm going to explain the process of takeoff in 2 dimensions. So how many people have done a quantity takeoff as a construction manager or seen the process or something? I know there's a few CMs in here, right? So there's not too many. This is good. I know as architects and engineers, there's a little bit of that you might do, but for the most part, right, you're subbing it out to a third-party guy who's doing the takeoff for you, and you know the cost of your job. I know we learned it in school. We're supposed to learn how to do takeoff. I mean, the concept's easy, right? It's an area times the price, and you've got it. Well, think about the process, and then I'm going to explain to you how you would do it, and sort of go back and forth, and I think it'll open up your eyes. This is a program called On-Screen Takeoff. There's a few different programs out there for 2D takeoffs, but this is one that we use. There's nothing wrong with this program. It's a great program. It does exactly what it's supposed to do very well. And so what does it do? It brings in your documents. So you send 2D documents, whether it's PDFs, etc., and it brings it in, scales the page just like you would on a full-size set. And then you can do things like polygons and get areas and lengths and linear foots, etc. Right? Kind of like Bluebeam. You probably use Bluebeam, where you can calibrate and then you can measure something. Right? So for those who are the Revit users in here, which I'm sure there's plenty, have you ever scaled an image in Revit? Some people have, right? So now let me ask you, when you're bringing in that image and you're typing scale and you're clicking the edge of, you zoom all the way into that rastered image to the edge of like a little black line, you click the right side, then you go to the next one, you scroll all the way and you click to the next right side of the line, and then you say 20 feet. How confident are you that that's really scaled accurately? I mean, let's be honest. You're not that confident, right? I'm not. I know for a fact, right? You're rasterizing a vector image. Okay, so you're zooming in, and it's going to become a thick line that's really 7 feet wide, even though it's only supposed to be a line, right? So, granted, these are going to be scaled a little differently because it's a full-size 30 by 42 inch, but in reality, that's what's happening, right? This is a rastered image now, okay? And then, as estimators, we can go in and let's use the blue as an example. We go in and we click, 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 and click, and we've got our area, right? Scale area. Okay. Same thing with the screen room. Let's go with the screen room, right? Click, 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 click. Right? All these clicks and you've got an area. Okay? Because it's scale. Now, again, for those of you using Revit, if I am a flooring subcontractor, let's say, or even a flooring rep, let's say I'm a carpet rep, and I call you up and I say, hey Jeff, how many square feet is in lab 102? You're the Revit users, you got some shops. How are you going to get that area? Think about it. Tell me right now how you get there. You're going to go into your model. You're going to either go to that floor plan, you're going to select that room element, or you're going to go to your schedule and you're going to go to that area and you're going to look at it. Right? You're not going to print out your Revit model to PDF, bring up a Bluebeam, scale it, and then click a polygon around. Are you? No. So why on earth do you want us to do that and then give you this accurate representation of the cost of your building? Right? Let's talk about counting now. That's areas, okay? These red blocks you see, right? There's a block here, there's a block here, there's a block here, there's a block here. Those are representing counts. Okay, so you can set up a condition, and you say, okay, I want all the red blocks to be my doors, or door type A1, I don't know, whatever. So you set up a condition, you go through, and then looking at the plans, you go click, 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 click. No offense, Lynn. Click, 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 right? That's how you're doing a count of how many A2 doors there are in your project. Okay, that's how we're doing a count of how many A2 doors there are in your project. When I first started at Turner 2 years ago, when I saw someone do this, it blew my freaking mind. I couldn't believe it. Because again, if you have, again, no offense, if you have Asa Abloy calling you because they're writing your spec for your door hardware, and they're saying, hey, how many type A200 doors or how many type 52 frames you have? What are you going to do? Are you going to go to your door schedule, print it out, highlight all the things, and count? No. You're going to go in your model, and you're either going to right-click all the doors and say select all instances, or you're going to go to your schedule, and you're going to filter by a specific thing. You're going to use your model to give them that data. Are you not? I mean, this is just counting doors. It's not putting the information of maintenance manuals on the door, right? You're literally just counting a door. So again, why, if we're responsible for doing the cost estimate of this project, why on earth do you want us to go in? Not only could it be, it's just a process that is an absolute nuisance to do when you think about it. Imagine sitting there doing that. It's like drawing total for the Revit guys. But you're also introducing human error, right? You're introducing human error in a process that doesn't need human error. Okay, when you have an Excel file, you sum and a total of a line, right? You don't go through and you say 1 plus 2 plus 3 plus 6 plus 4 plus 5, right? You know you're going in. Imagine doing that on a calculator versus summing the whole row. Human error. Same thing with light fixtures. We do the exact same example, right? Let's go to an RCP. I want to know how many R1 lights there are in your project. I got to go to all your RCPs, click, 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 click. Oh crap, that was an R2, delete, click, 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 click. Think about that process, right? Meanwhile, the Reflex Lighting calls you up because they're your lighting rep and they want to know how many R2s there are because they're trying to give you an accurate cost before it goes to the contractor. You're going to go in and you're going to create a schedule in your Revit model and you're going to say, here's all my R2 costs, right? So this is something that I know is super scary, and people, as far as the biggest, I'd say, we don't want to share type of mentality is because of this process and thinking about extracting this data. But when you think about you and your workflow and how you're using your models, it's not that different. Okay? I know that you're going to say there's some walls, some other things. Well, we're vetting the model, so we're not only asking you, what are you confident in this model, but we're also looking at ourselves and saying, hey, let's not take off this exterior wall to jump, right? So what are we using to do that? We're using a program called Assemble. So if there's anything you learned today, you learned a new software. It's called Assemble Systems. And what it is it has a plugin in Revit. So we get the model, check it out, vet it out, upload it, and it's really a 3D version of that on-screen takeoff you just saw. Instead of click, 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 now we're literally using schedules, just like you would, right? You can see here. There's our exterior wall, basic wall, exterior, etc. There's the square footage, the model it came from, and a bunch of information. So now, what this program does is, it's just like Navisworks or any other program you've seen using downstream, is it takes all the Revit properties and you can use them for whatever you want. So on the right-hand side here, you're going to see the type and the instance properties right out of the Revit model. So if you call that wall EXT, I can see EXT. Or if you set the function to exterior, I can see the function. And not only that, but of course it goes into Excel because we love Excel. And so you can export it straight to Excel, and you've got the data there that you can possibly use. The reason I like this software a lot, and some of you might, is that our estimators don't use Revit. Okay? They are not Revit users. Everyone here who is a Revit user understands the complexity of the software and the nuances and everything that's involved. So thinking about Navis and Revit and other ways than QTO, not only does it require a computer that's a little more advanced than someone using Excel and Word and PowerPoint every day, right? And Outlook. But it also requires a technical ability within the software that, unless you use it every day, you just don't understand, right? So this software is very straightforward. Fly it up. It's web-based. I don't know what I met the guys for this last week who created the software, and I asked them, what do you do to the model to make it so small? And they wouldn't tell me, their secret sauce, they said. But they do something to the model to make it incredibly small, even smaller than Navis files, so I'm not sure what the heck they're doing. But all the data is still there. So if there's anything you learned today, Assemble Systems is an awesome software, and I definitely think you should look at it. Even on the architecture side, think about a project manager or something, right? He wants to be able to go in and look at areas of the room schedule or something like that. Instead of having Revit on all their projects or the Revit viewer and dealing with that process, you can easily just throw it in Assemble and give access to that.
We actually had Assemble System give us a presentation 3 years ago.
Here or at BES?
No, at the BIM Council.
Yeah, they've been around for a while.
Yeah, so they've been around for 4.5 years.
Yeah, and they're doing some, in the next couple months, they're releasing some pretty big updates that look awesome. Bringing in the 2D Revit sheets, and you click model elements, and it'll pop up the view, so you kind of get that, because again, the relationship here is trying to connect the 2D and the 3D model to the estimator. That's the value there, right? So even if you're doing a takeoff two-dimensionally, you can have the model open where you can look at those corners and those edges and make sure you've got things right. Beyond just takeoff, having the data from the model to just do typical value checking or quality checking or even checking the work on your takeoff, right? When you send us a PDF of your finished plan, right? So there's a finished plan, there's a finished schedule. What can you do with that, right? So let's say you wanted to isolate all the RB1 base types, or all the rooms with RB1. Well, guess what? On a PDF, you ain't going to do that, right? If we have the model, we can export your finished schedule exactly like you have it here, and we can just set up a filter in Revit or in Excel. Right? So all we're doing is exporting data, filtering, and I can say, okay, PT1. So whether I'm doing that as a takeoff, or I'm saying, hey, I clicked around and I got 32 PT1s, let me make sure that it's right. Okay? Just inherent value in the model. That isn't scary. We're not going out and laying out the floors with this, although one day I hope it will. But we're using the data in a manner that is completely valuable and to the overall project as a whole, including the design team. So I won an Innovation Award at Turner, my first year in the company. And I know you're probably going to guess, if I asked you to guess what it was for, you'd probably say, oh, some cool Revit thing, or maybe that cool video you just saw in the beginning, or maybe a Dynamo script or some kind of automation, some real technical geeky stuff, right? No. The Innovation Award I won was for 3 Word documents that I created my first 3 months at the company. Word documents, okay? And the reason they've become so valuable is what they are a handoff we give to the design team at the very beginning of a project that not only does it explain some of the stuff you're talking about, what I'm talking about here, about, you know, safe, but it also has what's called modeling best practices for quantity takeoff, is what I call it. And so this is, I'm only going to highlight a couple of them, but it's a list of about 15 to 20 things that the whole goal is to be non-intrusive. So I don't want to go in and say, this is how you should name your families, this is how you should name your walls, this is how you should change your templates and your view filters and all this other stuff. Right? Because I understand as an architect and a previous BIM manager for an architecture company, that someone tells you come in and change your naming conventions, you're going to throw them out the window, right? So just think about things on a day-to-day basis when you're modeling or you have a team that's modeling that really, at the end of the day, are going to make your drawings better and they're going to make your models better, and they really don't do much to impede your workflow, okay? So the first one is proper wall functions, okay? So when you're in Revit and you build a new wall type, there's a thing called a function. Most of you know this. You can set it as exterior, interior, foundation, or curtain wall, okay? Just by doing that, think about the downstream uses of that. So setting all these walls here to say interior function, you can call it whatever you want in the naming convention. Someone can say filter by function interior and they have all your interior walls. You can do it too, right? Not just us. So that's one of the things that I see a lot. Top of wall constraints. I know this one's probably a headache for some of the BIM managers in the rooms anyway. Making your walls go up to where they're supposed to go, right? An interior wall doesn't always go to the ceiling, doesn't always go to the deck. Sometimes it does both. Sometimes it does here and there. So just make sure that happens. And that's something that I know can be tough and difficult, but over time, Revit users, they begin to realize that, oh crap, this stuff is being built in 3D. And once they start realizing that, then they start checking and you can see how that is. And the reason for that is for obvious reasons, right? You can do takeoff and you can do areas of walls that are much more accurate. Not only that, but also coordination downstream. You now know which walls go up to the ceiling, which walls go up to the roof. That can be important for subcontractors trying to run through those walls. This to me is my favorite, and I think it sort of combines everything that we just talked about in extraction, and that is if you can schedule it, we can schedule it. So if you think about this every single day, every project you're ever doing in Revit, your models will be 100 times better for you and for anyone downstream, right? Think about the lighting, for instance. Okay, if you can go in your model and you can isolate all of your R2 light fixtures, so can anyone else using your model 20 years from now. Right? So think about the value there. Right? So if you can schedule it, anyone downstream can schedule it. Rooms, doors, windows, you name it, anything. Furniture. Furniture kind of goes to the next piece here. A basic 3D box with data can be counted. Annotations can't. Okay? I'm going to give an example that might not seem like the best example, but for some reason it's always drawn in 2D. Mop sinks. I don't know what it is. Maybe it's the Revit models for mop sinks, but for some reason, mop sinks are always two-dimensional elements in floor plans. Okay? So when it's a 2D detail element in a floor plan, sometimes you can schedule it as a 2D element, but in reality, you can't, right? You can only see it in that one view in that one floor plan, and that's it. So if I'm the plumbing subcontractor and I'm going through the model and looking for something, or maybe I'm on the blow-up detail that didn't copy over or something like that, right? I don't see there's a box there. Not only that, if I am the estimator and I'm trying to take off, or maybe I'm the architect and I want to know how many mop sinks are in this building because I need to make a spec for it or something like that, right? If you didn't do it in 3 dimensions, if you didn't create even just a stupid little box that has data that says, hey, I'm a mop sink, then you can't schedule it, right? So I'd rather see a box that was, you can create it in Family Editor, I don't care, it could just be a box, but that box is a little piece of data that says, I'm a mop sink. Done. Okay, because that can be, not only can it be counted, but it goes right back to this one here. If you can schedule, we can schedule it, right? Principles to live by with Revit. That's what I should call this. And then finally, SketchUp syndrome. I'm hoping because we're at the BIM Council, there aren't a lot of SketchUp users here, but I know there might be, and I don't want to offend you too much. This is the only time I'm going to use the word SketchUp in this presentation, I promise. But what I call SketchUp syndrome is model in place masses, okay? So I'm going to use an example here. I'm not going to talk about the project or the architect or anything, but I just want to give an example. So here's a project, okay? I'm going to isolate generic models. So this is just the generic model category, isolated, okay? And then this is SketchUp syndrome. You know the sketch below down. So See these exterior walls, all these fins, all this stuff over here. These are model in place components, or masses, if you want to call them. Okay? For those of you not familiar with Revit and what that means, instead of clicking, click from here and click to there, and it draws a wall at 8 feet tall, and that wall says it's a 12-inch thick masonry wall. What it is drawing the outline of all of this stuff in 2D and then extruding it into 3D. So it's a big mass. Okay? There's value to it because you can at least see it, right? But there's no value to it downstream. Right? You can't take an area off it, you can't take a linear foot off this, you don't even know what the hell it is unless they named the in-place mass something. So we're going to say no schedule syndrome, so that definitely before you put model in place, think about it. Okay? That's what I call schedule syndrome. So that was a little bit of extraction, and I'm glad no one ran away. That's good. So it must not have been too scary. That's good. Now we're going to get a little bit into construction and then operation. You think this is the meat of the presentation, but believe it or not, all that stuff, B and E, is a lot of what I do every day, more than construction. So construction, yes, there's aspects you're going to see that are very valuable, but there are aspects that you've already seen that are pretty common now. And so the V and the E, the pre-construction and as well as prepping up and planning the job, is really what helps the job succeed. Here's another D. We're going to talk about 4D just because I should talk about it because it is something that happens. It's happening every day now, and more people are asking for it. And so what is sequencing? What is 4D? So everyone here is probably familiar with a Gantt chart and a schedule. They've probably seen some sort of a schedule of a project. The linear schedule here, it's got tasks. Sometimes it's really, really finite, sometimes it's not. It's a little more summary. And so if we have a model and we have a schedule, 4D is very, very simple. It's linking the two. Okay? So you take a task here. So let's say this task was called install K-bracing. Select K-bracing, you link it to that task. Okay? It's a direct link between these two pieces of software. Then what you're able to do is you're able to run it through a sequence and you can watch the building grow. And I think we can sort of gather our own examples of how this will be valuable as far as sequencing, planning, even safety, seeing the building going up, right? And so I'm going to give just a little example. This I did not do. This was our main office, and I'm not allowed to tell you the name of the project because apparently it's super top secret. But I really liked it because it's a good visual, but it also explains the process really well. This is something that we would not open Connecticut, I can guarantee you that. There was a bar on the bottom here I had to hide because it said the name of the project. But essentially what's happening is we've got a Gantt chart, and we're running along the time frame, right? And now you can see exactly what's happening throughout each piece of time. So all these elements here that you're seeing going up, each one of these elements, a little bit, so you can't see the core, but each one of these elements, they're attached to a piece of time. And maybe 15 pieces are attached to one piece of time. But what's happening here is now you can see how that Gantt chart, how that schedule, which again is so important to a construction manager because critical path scheduling is really a big deal of what we do as far as construction is concerned. You can see how it's going to go together. You can pause it and you can say, hey, that doesn't look right, maybe I should tweak it. You can verify your schedule. You can show subcontractors and they'll get a sense of, oh, this is what they're thinking, instead of looking at a piece of paper. I mean, it's not too different than looking at the 3D model instead of a 2D set of drawings, right? So now instead of looking at just a Gantt chart, which can be telling, depending on who you are, now you're visually seeing that Gantt chart. So this is just going to keep going on. It's a huge freaking building. But you get the idea, right? So it goes up, it marches all the way up. This was actually pretty cool. The guy in the New York office that did this is pretty good at programming as well. And so he had a web-based viewer where you can slide along the time frame and you can see any moment in time. So imagine the value in that, right? And then you can keep it linked. And I think most people here can extract what they think would be the value of that. Coordination, I'm going to graze over because I know as far as you're concerned, this is probably what everyone knows BIM is used for. You've probably all been involved in the process. And hopefully during design you're all doing it. And you've probably even seen this image or something similar to it. Coordination is very simple, right? It's building the building before it goes up so that we make sure everything fits. It's really all it is. And so typically what we're doing as far as the process, so you know, is that we're taking the architectural model, and depending on the job, it might be a steel model from a subcontractor, or it just might be the existing steel model. And for the most part, our subcontractors are rebuilding the models using the engineers as guides. So they might bring in the engineering one. There are some jobs, actually, that Bennett, I forgot who the engineer was, I think it might be CES. Yeah. So the subcontractor actually said, wow, this is pretty good. So they must have coordinated beforehand. You know, they were following the paths almost to a T of the engineering job. They said this is the best route. Sometimes it doesn't happen, right? There's stuff that comes in the way. But really, you got the space between the floor and the ceiling. You've got a certain amount of room that you can play with, and all the guys got to play in the sandbox there. So what we're doing is we're running coordination meetings, weekly coordination meetings, and we're making sure that usually a floor at a time or an area at a time, signing off, saying this is ready to roll. Now by the time you hit the field, in theory, there should be 0 problems. In theory. Granted, it's not going to happen, there's always problems, but there's going to be way less problems than there were in the past. So, how many people have seen something like this before? Anyone seen? Maybe? Okay. What this is here, this is a clash report from Navisworks. So what we use to do our clash detection is Navisworks. I know some of you who are Revit users might just use the Revit clash thing, which is a whole other issue, we won't get into that. But this is what we're using, especially because there's a lot of different programs out there, right? Some people are using AutoCAD MEP, some people are using Revit, some people are using Civil, whatever. So this can bring all the models together, and then we can clash. We can look at coordination. The problem is this is literally the default clash report. You can't do anything with it. So now, if I am a subcontractor, even if I'm intimately knowledgeable about this job, and I look at the location, 10.492 feet, 115.38 feet, 20.61 feet. That's the location. And then there might be a little bit of a, column, grid location B3 level 2. So think about if I just gave you those 2 pieces of information as Revit users, and you had to go in your model and find that location, good luck. It's not easy, right? There's a little image, if you're in the Navis model, you can click to it and get to it, but you still have to go back in Revit to fix it, right? So one of the things that I did that seems to be really improving this process is I created a script that helps alleviate this challenge. Okay? You can't do a Revit presentation anymore without saying Dynamo, so I have to talk about Dynamo. I know we had Dynamo, the last BIM breakfast was Michael O'Kelly, who's I don't think here today, and he talked about Dynamo. So this is a little scary, there's a lot of notes here. But one of the great things about Dynamo that I don't know if Michael talked about is that it can talk to multiple software. So Dynamo is a pretty easy to use visual programmer. So instead of writing a whole bunch of lines of crazy code and figuring out the language of code, you use little nodes and you can sort of plug things in and get stuff to happen, especially repetitive tasks. But because it's an Autodesk, open source Autodesk program, it talks to multiple pieces of software. So Dynamo can talk to Revit and it can talk to Navisworks. So when I saw that, and some dude in Australia named Adam, who's awesome, wrote a couple of Python scripts that actually allow you to get specific clash information from Navisworks. We can link it all up together and we can do some cool things. So on the right hand side is Navisworks. So we have a clash, lights and diffusers, because that never happens, right? So 4 clashes in this model. And on the left hand side, we have our Revit model. And so what we're going to do is we're going to use this Dynamo script to place a family that I call this clash sphere in those locations in your Revit model. So see those red blobs that just popped up? That's an adaptive component I created called the clash sphere. That can be as big, as small as you want, whatever color you want. Not only that, but it also, if you click it, it has a piece of data that in the comment field telling you exactly what clash it was from the Navis report. So now, with the click of a button, you can bring that information into Revit. You can create a separate Revit file if you want, hand it out to your subs or engineers or whoever, link it into their model, and they can say, hey, all those yellow blobs are you, dude, go fix it. Right? How much easier is that than going through the entire process? If you've ever sat in a coordination meeting, you know that the most time spent is figuring out where the freaking clash is and whose job is it to fix it. So now, we're still going to figure out whose job is to fix it, but at least we don't have to spend time figuring out where it is. And I got an additional word for it. All right, field coordination. This is pretty basic, but it also kind of ties back into visualization. We are using BIM 360 Glue, BIM 360 Field. You probably all heard the buzzwords. Procore is one of our document management systems. Because we're using Procore for a lot of our submittals, changes, and field issues, we're not using field as much as we are using Glue. There are jobs where we're using Glue instead of Navisworks as full coordination, because the power there is that you can upload a model into Glue, you can do your full coordination with the history of all those changes in RFIs, and then you can hand it off to the field team where they have access to that model, because it's all hosted in the file. But the one thing I want to talk about is that's pretty much all it is. It's viewing in the field, which I think the visualization part sort of drove home how that's important. But the one thing I want to talk about is QR codes, because I think more and more on both sides you're going to be hearing nothing but QR codes, QR codes, QR codes. Reason being is this is how you can access the data from the model in the field quickly. And so it's becoming extremely easy to do and extremely popular, and we're actually doing it on projects and we're being asked about it quite a bit. And so this is a video of BIM 360 Glue for those of you who are familiar with it. It's a little bit older, so the process is a little easier now.
You're working in markup. It's all happens within the tied to individual merged views, right? So now that it's view merge, I'm going to create model merge. I'm going to create a view. In this case, I'm going to call it QR code test view. Let that save. Now we have a saved view that we can get a hyperlink for. So any action that takes place inside of a merge model in Glue has a hyperlink associated with it. So if I go down to the collaborate tab, which is here at the bottom, and then go to the record subtab and hit list to refresh it, you'll see that it's telling me that this is essentially the audit trail of the whole project. Every action that's taking place on this project is captured here in this spreadsheet. So it's saying the last thing that happened was there was an action that took place to QR code test merge model, and the action was that I added a view. The view was called QR code test view, and the user was kind of DOS, and the date was 416. So again, it lets you know everything that's happening in this model, who's doing it, and what we're really concerned about here right now for the purposes of this pilot is getting the link. So I just, by clicking this blue hyperlink, I can copy the link for this view to my clipboard, and I can paste it into Excel. So this is a really simple little Excel formula using the concatenate tool to concatenate the script language I need, the language I need to tell Google Charts how to write this QR code, and what should the hyperlink be for the QR code. So just so you know, Google Charts is a pretty cool little API they have. It allows you to create charts of a lot of different flavors. In this case, what we're doing, if you look at the syntax here, we're creating a chart of size 500 pixels by 500 pixels, a chart of type QR code, and a chart with a link that's this data here, the b3.artist.com link. So now that I've got that URL all put together, I can copy it and paste it into any old browser, and you get the QR code back at you. So now we've got that all established, I'm going to launch my iPad. If you haven't seen this before, this is an application called Reflector, which allows you to mirror your iPad screen or your iPhone screen on your laptop just like you would on any AirPlay device. So I'm going to use Scan here, which is a very simple scanning device, QR code recognizer, and I'm just going to hold up the screen, grab that, see if we can focus, it should launch BIM 360 Glue, and take us directly to that. So you see it hops right to that view.
So I think all of you can imagine all the possibilities something like this can do, right? I know one of the ways we've even done it beyond just construction is on 2D drawings. So you can put a QR code next to a detail, hit it, and then you can pull up a 3D version of that detail, right? That's pretty cool. We've done it, VR again is one of those buzzwords like Dynamo, right? Where there's a rendering of an image of an OR. We had a hospital in Yale Center hospital, so we were renovating a whole bunch of their ORs. And we needed to verify equipment locations with the surgeons. So what we did is we created a VR model that they can look around and they can see all those pieces. And in order to get to that model, all it was a rendering with a QR code that opens the link and opens the model. So stuff like that's pretty cool, where QR codes can come into the play even before construction. But really, the reason I wanted to show you that is that it's one of those things that I know you hear about, but you're probably like, how does that really work? Well, that's how it works. It's very easy. Operations 1, where I know we had one facility manager guy who was interested in it. Unfortunately, it's still, I would say out of all the stuff we just talked about, our D, E, and C, operation is the most infancy. It is being asked about, and I'm sure you're seeing that owners are asking about it because they're starting to hear the value, even though they don't necessarily know what it is, they're starting to hear the value of these models. And so operation is one of those things that's going to hit us in the butt, and we need to get ready for it. So what I want to do is just sort of introduce the concepts to you, and maybe explain a little bit about how we're doing it. But most of the projects here in Connecticut are either in the process of figuring that out, or they're going to be in the next year or so. I know across the country, I've talked to plenty of other EDC managers where they are doing it, and mostly hospitals is a big one, but they're creating these turnover packages of models, etc. So the big thing with operation, the easiest thing to understand would be systems management. So this goes not as far as completely controlling your building using the model, but it's really going back to this, tying back to this idea of QR codes and what the process would be. So I'm sure you hear it all the time, oh yeah, you took a piece of the mechanical equipment and then you get the maintenance manual or the schedule from the model. Well, I just showed you how to create a QR code and link that information. Depending on software you use is different, but that's all the information, right? So you know that. So what's the process? You create a set of construction documents. We build the building. The MEP systems are installed. When those MEP systems are installed or during the process of construction, use this QR code link in whatever software they use, and you can input all that information. So you have the model there, you input your schedules, your maintenance, your books, you name it, right? And then that's linked to the QR code. Then we turn the building over to the owner. Right, so now they have the building. Now all the owner has to do is hopefully they have the software. A lot of the software now is web-based, so you don't need software. It's just a HTML or PHP. So all you need to do is be able to know how to scan a piece of QR code, right? Which, for the most part, most people know how to do now, right? QR codes are pretty powerful. So we're taking this whole chunk of complexity out of the process for the owner and saying, hey, just go around scanning your QR codes and you can figure it out, right? So that's the system management part of it. Moving downstream even more with sensors and running the building, all that stuff, we're not going to get into that. The goal would be, sure, yeah, that'd be awesome to have, right? You can sensor each room, you could have this model, where you can calculate flow. I mean, you go down it. At its very basic form, to me, this is operation right now as it stands. And this is what you're going to see more than likely right now as it stands. As-built models. Ooh. How many people have been required to submit record or as-built models on a project? Lots of people, I'm sure. How many people have any idea what that means? Yeah, me either. Neither do the owners, honestly. So it's because it is the trend now, and it's a good trend to use building information modeling. Owners are asking for models in return, right? And they're calling them as-built records, paying the contracts going through it. Well, to me, an as-built model or record model is the most accurate representation of the construction that we can get. Without going into LODs and what it should be, I don't think that even matters. I think it just needs to be an accurate representation, right? There might not need to be floor bases on this wall, but the wall should be in the correct location, right? So one of the things that we're doing is laser scanning is getting huge. You've seen laser scanning, it's freaking cool. It's so easy, it's so much cheaper than it used to be. And we're using it at Turner as far as as-built models are concerned. But not only as-built models, but also QA/QC. So let's say, a perfect example, this room here was built off of a set of documents. It's a brand new building, it's built off a set of documents. We go out, we laser scan it, we import the laser scan into our coordination model or your model, right? And now you can check, hey, is this beam, is this beam right here, or this ductwork, is this all where the laser, where the model was? If not, why? Right? So that's QA/QC, it's simple, right? And then if it isn't, shift it over 2 inches. Does it really matter if there's a flange on this? Not necessarily. I mean, yes, for coordination it does. But in reality, now you're handing back the owner a model that you can confidently say represents what was constructed. So to me, that's what an as-built model is. Until they start defining all that information that needs to be required into it, and LODs, and we can go down that bandwagon, we're not going to today. To me, that's really what it comes out to. And so laser scanning is big. We're also, Turner itself is investing in some total stations. They're doing some as-built point spot checks, etc. Just to make sure that stuff is being laid out exactly how we want it to be, whether it's through the designer's documents or whether it's through the coordinated documents. Another example of laser scanning and how it could be helpful on an existing project. This is a generator room in Northern Westchester Hospital. And so we're at an existing generator, the green scan here with some other stuff, and then these are 2 new generators we're replacing here. So we had the owner was really into it and asked about the process of laser scanning and how much it would be, etc. I was excited about it because, hey, laser scan anytime I want, right? That's pretty cool. So I'm not going to be against it. So we went out and we laser scanned the project. It ended up being super valuable because what I did was, without getting an accurate generator model from our vendor yet, they were trying to get one, but even to the point where you have all these steam valves and all this craziness going on the side, I just took the laser scan of the existing, copied it over the point cloud twice, including all the piping. We also modeled based on the laser scan. Copied it over because we knew it was going to be based on the same thing. And then you can start coordinating it long before you even have that information. So we knew right away, just by doing this, that hey, this silencer's got to move. All right. Originally in the documents, the silencer wasn't moving. They thought they had enough room over here to place it. So by doing this, I don't know how much that would have cost. I'm sure we can quantify it, but going in there and figuring out we have to move that and not knowing it can be super expensive. Same project here, we have a switchgear installation in that same, it goes along with that generator. You can see the existing steel model on the top with piping, lighting, sprinkler piping, etc. What we discovered here is, hey, this isn't going to work, right? Look at the top of this gear here. Well, how the heck do you, if anyone knows any switch gear, you know that you kind of need to access that, right? So we realized, we got to figure something out. We ended up, not only did we actually shrink the switch gear, change the pad, we had to move some of this piping obviously, but we also found out there was clearance issues with the switch gear once we put it in the real model. So we shrunk, we had to change it. So again, those are issues. This wasn't a huge job. It was a 1,600 square foot mechanical room, or a generator room. But that could have been the entire cost of the job, those 2 issues that they came up in the field. So that's not necessarily as built, that's sort of a existing conditions check, but it's a nice example of how laser scanning is being used. So I know that was very fast and a lot of information stuck in, but I think think what the goal was, and I hope most of you, I can tell by your faces, you're thinking about all these things, is to really inform you about what happens, right? And so by going through these categories, these buckets, we can start thinking a little bit about how the model is being used, and by knowing that, right, just like when you're designing a building, knowing how it's being used helps you design it. Same thing with building. Right, so the other thing I wanted to mention, let's go back to Tip and Top now. So remember how scared Tip was to share his balloon, right? He was very scared. He didn't know what Top was going to do with it. In reality, when Top got the balloon, they ended up making it better, right? They could share everything with it, right? So improving on Top. So the other thing I want to mention too is this entire time, did I ever mention title blocks, templates, families, naming conventions, all these little precious things that are in Revit models? No, right? Because the goal here is to let you know that your models are safe, okay? You don't have to sit there, you don't have to spend 3 hours extracting title blocks, families, etc. For the most part, it's coming in, getting the model, exporting it to another piece of software. That's about it, right? So I want to let you know that your title blocks are safe with us, your templates are safe with us, and your precious families are safe with us, okay? All right? We're not going to take them. We're not doing a set of documents. Okay, so if anything you took away from this today, I hope you feel a little safer and a little better about using your models now. So before we go into questions, I wanted to do something really fun really quick. And I have 2 t-shirts here. So for those of you using Revit, I think you'll like it. Okay, so I have 2 large t-shirts, sorry, the only size I have large. And we're going to do a little giveaway. And so, being the Revit geek that I am, I created a Dynamo script that's going to run a shuffle through all the list of attendees. Okay, and it's gonna pick a name after you. Okay, so let's do this here. If you want to know the Dynamo script afterwards, I can send it to you. Okay, so again, this is linked up to your thing. So I'm going to click run, and the first winner is, come on, Kelly. Winner. Sorry, it's a large. You were definitely not a large. Okay. So, it didn't die, yeah. Unfortunately, the shuffle will keep saying Cali unless I place it back in. So let me just do that again. So let's run it one more time. Okay. Francis Murphy, you here? No? All right, sorry, Francis. You're lost. Try again. Francis Murphy, are you online? No. You have to be present. Yeah, you have to be present. Yeah, I'm not checking anything out here. All right, one more. Let's run it. Yeah. Winner. Now, I'm sure there's plenty. I don't know how much time we have, but
Plenty of time.
Plenty of time? All right. Well, I know everyone doesn't want to get back to the day job, right? I was told by Jerry to make it as long as possible. All right. So let's start. Who's got a question? No questions. That's impressive.
I have a question. Going back to the extraction part and just being safe about that from the design standpoint. I think we're trying to get there. Part of the trouble that we see even internally is that we're not using it enough for what we're delivering to know that you're then using it. And so the fear, I believe, and it's better for the project as a whole, is that you're going to find our mistake, not us. Because we're finding as we QA our models, our BIM team in our office, that you go through best practices, people aren't always following them. So the doors, and you're counting the doors, somebody put a door in just on the paper because that's what the principal was QCing, the 2D document, not the model. So we're trying to get our PMs to be QCing the model more. And it's just tough in the current pace and delivery scheme that we have. So it's just a challenge.
Let me ask a question. Do you have a problem with us finding a mistake in the model?
I don't.
If we tell you about it.
It's human nature that we'd rather find our own mistakes.
Oh, I know.
And contractually, depending on the project, there's an apprehension by our ownership probably more than, you know, those of us doing it. I'd rather you find the mistake virtually before it's a field issue that the problem's more expensive to fix, less attractive to fix, but it still comes down to human nature, you know, so playing on that fear side of things that you brought up.
And I'll tell you right now that I don't think there's a single project yet where we were able to take off every single piece, right? So you know, you have to educate the estimators as well as look at the models to a certain point, as well as talk to the design team. One of the things we do is we try our best, and I think we're doing pretty good at it, with discussing with the design team how we're going to use it, and then they sort of get an idea, and they might say, don't look at those doors. You know, we've had that numerous times. Don't look at my roofs, it's don't even bother, you know. But at least there's still value there, right? I mean, there's still value there.
I know our process at PES is to engage in the conversation. Anytime our model is requested, that's fine. Let's just, you and I talk for 5 minutes. What are some of the things that you're looking to do with that model? So that we understand and we can give you a heads up. Hey, I'm not that confident right now in that element being modeled in all cases because the designer may have been in a rush and just annotated some of that.
Correct. And I think the 3 documents I was talking about, I think that's why they became so valuable. Not necessarily the information in them as much as the second we send them, it forces communication with the design team, right? Because whether it's good or bad, what the hell are you talking about? Or it might be, hey, you know, this is kind of cool, let's talk about it. It's what it's doing is it's forcing that communication way up front instead of at bid time or MCDs. Go ahead.
I think just to further that, I mean, I think from the estimator's perspective, and inevitably we're conveying information to the client, it's not mistakes that were really, the reality is they're incomplete at that point. We understand that they're incomplete, and it's our job to make sure that when we look at something, let's say it's doors, we need to have built-in metrics that say, are the quantity of doors that we're finding from the model, does it make sense? If we're looking at an emergency department and our door density is one door per 500 square feet, we know that that's incorrect. And so it's our obligation to then go back and say, well, we know we're missing some stuff, what's going on. And that's kind of an easy one, but there has to be, from our perspective, there has to be checks and balances to incomplete documents. Otherwise, we would never be able to get to what is the reality of the answer. Because even in the 2D world, you know, we know the information is not complete. And so the model is great because we can start to visualize. So if you think about as an estimator, there's quantification, which is great, but quantification with visualization, which is the first thing you're going to talk about, is really important for the estimator. And so we're getting both of those things from the model, realizing that forget mistakes, it's incomplete. And again, that's our responsibility to have that level of communication to then say, what can we use it for? Okay, the steel is there, but we're not confident in that total quantity of steel, let's say at 10%. Okay, great, you know, that's fine. And we do that all the time. I think that's the part of it that once you go through it, you realize that it's not an invasion. And even the word extraction may be having too many negative connotations.
I need a valve.
But I think it's I think that's a part of it, is to realize that we completely understand the incompleteness, and we want to work through that together.
Yeah, I mean, when I first started introducing it, so originally when I first started, there was Navisworks. I was doing some of the takeoff. And in order for them to see models, instead of installing Navisworks, I actually had estimators flying around in Revisto or like, you know, those gaming type of programs. So you had all these estimators flying around going crazy. But really that was that visual thing. They can look at the corner of the building. But one of the things that I never thought about is all these checks that are so easy to make sure, right? So exterior wall, for instance, perimeter times height. If you get a square footage of the perimeter building times the height, that's pretty close to, you know, at least to give you a gauge. And then all of a sudden you take off on the model and it's, you know, 20% less than that, you know something funky's going on. Tonnage of HVAC stuff, sheet metal, tonnage of steel. You know, there's all these checks that me as an architect I hadn't even thought about, but they're really easy and quick to do, where you can say, oh, that model's garbage, or maybe, hey, I'm not extracting information right, or I'm not isolating right. And so, me being an architect, not realizing that there is this sophistication. The contractors are more sophisticated than I thought it was. So they do have a little bit of understanding, and there are people like myself, and most of the VDC people across the country for Turner are actually architecturally trained. And I think there's a reason for that. It's because the technical knowledge of the software itself lends a hand to the stuff we're talking about.
You can dominate the question.
We got coffee out of this one.
Well, before I go, does anybody else have questions too?
Good time.
Where do you see the future of liability or imbuing models with contractual values in terms of?
Someone always brings up contracts.
Yeah. Well, because it's dollars.
No, it
And
is.
valuing. If this architect does a sloppy model and this architect does a thorough model, where is the variance in value? How does that filter downstream? You know, and in order to do that, you have to have, it has to be reflected contractually in the client.
I agree. So I think personally that the only thing holding us back from creating the 3D models is the contracts and lawyers, personally. So I think that contract, you're seeing all the different types of contracts coming out, all different ways, right? An execution plan, setting up an LOD, you know, going through the process of an execution plan to sort of set those standards for your specific project. And then, yeah, realizing if there is a value there, is there cost. There's a project we worked on, I won't say the name or the firm, but at the end of it, after the contract was signed, the owner decided, hey, I want you to do design team coordination. So before, you know, during at DD, at CD, or 50% CD, I want you to do clash detection, do legitimate coordination on this project. Well, the architect said, hey, yeah, that's great, but, you know, this is going to cost money. And luckily, it was an owner that understood that, and the contract was adjusted and they were paid. As far as the legality of it, I think it's just a matter of getting to that point. You know, doing a few projects, whether they're case study projects or just someone being a little more riskier than the next person and saying, yeah, let's try and build this thing from a 3D model instead of a 2D and sort of working our way up to it. As far as how that gets there, I don't know. I'm not a lawyer. I don't pretend to be. But me personally, I think that's the only thing holding us back to it. We are on the contractor side. They're laying out robotic layout, all this other stuff from models is happening, right? If subcontractors can go there and build an MEP rack that can be built off-site and put into a building, then you can, from a model, right? They're doing that from a model, then the same can be applied to pretty much any part of the building. You know, so there's so much involved in the legality of it. I won't go down that road, but I'll just add the fact that I think that's the only thing holding us back.
Even to say though, beyond that is a change in the delivery method of the projects, you know, not just the legal aspect. So moving away from design to build and things that really accentuate technology and being used on projects is something else that has to happen. And with that, obviously, the changes in contracts will happen too.
So for those of you who don't know, I am a construction lawyer. But
so Nancy's holding us back.
Not me personally. No. One of the things this group is doing, and I think it's really important, if you think about it, contracts are not written by people who actually do work. Contracts are not written with processes and implementation in mind. And one of the things this group is going to be experimenting with over the course of the next year, I'd say, is right now we're working, there's a working group looking at best practices for model sharing and how things should be done. And we're going to take that concept, how things should be done, and play with the idea of translating that into contracts that actually work. So we're going to be working on that and let it coming clear.
And I purposely went through an hour of all the slides. I didn't mention contracts once. I know people think about it, right? But there's a reason for that, because when you step back and take that out of the equation and you look at it as a whole, other than contracts, this is silly, some of the stuff we're doing, right? And so the only thing that's stopping it might be a contract. I want to at least look at it as a whole, and we can force the contract to catch up.
Right.
Go down.
Just kind of to follow up on that, like, so all the IPD projects that I've worked on are kind of CD level models that we deliver is not as complete as sometimes you would have when you really draw more kind of details. It's really just about the model itself. So then how do you envision this kind of in a CA situation in the phase of, like, do you think that shop drawings or more the architects will continue to kind of develop the model in a post kind of 100% CD delivery that like kind
No,
of
I
continues
think-
it going, or, I mean,
No, no,
because
I
when
think
you
there's
deliver a
still a level-
CD, your model's not always,
Right, so there's still a level of expectation that has to be set up front, right?
Yeah.
And I think, yeah, we could get to that level, but it wouldn't necessarily be the architect doing it. You might be, one of the big things now, Turner out west especially, we've got a lot of subcontractors that are fully modeling cold form metal framing. So
Yeah.
they're actually going out and so they're taking the architectural model and they're just taking out the guts, leaving the gypsum board, and they're filling it in with studs. Right, so if you get to that point where now you have subcontractors who are the ones building it, doing this, at the end of the job, you've got almost every single element built of the
but
project.
in that place too, like the last job I worked on, we were co-locating with our
Mhm.
contractors, you know,
Yeah.
I mean, they're building that while we're still building our.
But that doesn't have to be an
model.
IPD delivery method for that to happen, and that's the thing why I like to take contracting out of it, because yeah, IPD, because IPD I feel like scares the crap out of people, even though the concept is great, but it's